Good morning, class. We are looking at section 3.5, implicit differentiation. So we have covered various techniques of differentiation, such as dealing with polynomials, exponential functions, product and quotient rules, trigonometric functions, the chain rule, and we are going to move on to this new section, the implicit differentiation. There are a bunch of formulas that we have seen, and I hope everybody remembers all of them because we need them to move on, okay? Now, this is everything from previous sections, and now the idea of a implicit differentiation. And why do we need that? When we are given a function may be explicitly defined or implicitly. When we say explicitly, we mean, let me just get my pointer here. Explicitly, you notice this function, y is a function of x. So y is a function of x. Explicitly, and we know how to deal with that. However, if you look at this case, or this case, those are known as implicit functions. That means, in essence, x and y are intertwined. So sometimes it's easy to solve for y and go back to the explicit format. Sometimes it's not. That's why we need to use both methodologies. So let's start with a very simple example, and we're going to do both methods, and we see that both result in the same. But again, there are cases that either it's extremely difficult to solve for y, or in some cases even impossible. So let's start with 4x plus 2y equals 10. If we want to go with the explicit method, the very first thing we need to do is to solve for y, which means we move the 4x and we divide by 2. Okay, so I'm assuming everybody understands what happens. We move the 4x and we divide by 2. When you move the 4x, you get negative 4x. So this is the right side. If you divide it by 2, becomes negative 2x plus 5. And this is a very simple case. Y prime or dy dx is simply negative 2. So that's the good old method. We know that it's not a big deal. Now, what is the implicit methodology? The implicit methodology says when you are given the function, okay, 4x plus 2y equals 10, we differentiate as it occurs. We don't change anything. 4x, everybody knows the derivative is 4. But what about 2y? Understand y is a function of x. So 2y, the derivative is 2y prime, and 10, any constant, okay, the result is 0. So whether I write y prime or dy dx makes no difference. And I want to put it in both formats, y prime and dy dx. So just to refresh your memory, either way is absolutely fine. This is a simple algebraic equation. Move the 4, divide by 2, and it gives you exactly the same answer. Now, this was the simplest example I could think of to show you that they give us the same answer, class. So we know explicit differentiation. Now, implicit differentiation is fairly simple. Just remember the derivative of y is dy. So think of it as f of x or g of x. The derivative of g of x is g prime of x. So literally change the y to g of x if it gets confusing. So having said that, let's look at this example. This is an example of a circle centered at 0, 0 with the radius 5. We want to find y prime or dy dx, and then we want to find the equation of a tangent line at a specific point. So let's differentiate it just the way it is. Needless to say, I highly recommend you try to solve for y because it is doable, and do this at home, solving explicitly. So implicit differentiation, let's see what happens. X squared gives us 2x. But what about y squared? And think about this. In fact, I'm going to write it at top in case for now until everybody gets comfortable with that. Instead of y squared, you can actually write, let's say, g of x squared. So I want to make sure we understand what's happening. When we differentiate g of x squared, we get 2g of x times g prime of x. So it's the same thing. Y squared gives us 2y, y prime, or dy dx. And of course, the number on the right is 0. So let's quickly recap. When you differentiate x squared, you get 2x. That's not a big deal. But what about y squared? Y is a function of x itself. Think of it as g of x, okay, which is being raised to the power of 2. So this is really the chain rule, 2y, y prime, okay, class. By the chain rule, the derivative of g of x squared is 2 times g of x and then times g prime of x. That part is by the chain rule. So we are here. Now, simply put, move the 2x, you get negative 2x, divide by 2y, and that's your y prime. So that's a simple algebra. So after we get the first step, the rest is just algebra. So what is part B? How do we handle part B? Well, we need a pair, it's given. We need the slope, just plug in. When you plug in the pair, okay, replace the x with 3 and y with 4, that's your slope. So you got your slope. Y minus y1 equals m times x minus x of 1. That's a very simple case of a point slope. And we can come up with the answer. I'm assuming we know how to do this. Just quickly showing you. This one is, let's just write it here. Y minus 4 is negative 3/4 times x, and then times negative 3 gives us plus 9/4 minus 4 is plus 4, which is 16/4. They add up to 25/4. That's how we arrive at it. That shouldn't be a big deal. I hope everybody's comfortable with this. Okay. All right. We're going to move on, and basically we are going to practice. We're going to practice x cubed plus y cubed equals 6xy. All right, I think x cubed is pretty straightforward. 3x squared, 3x squared. But what about y cubed? What is the derivative of y cubed, class? Anybody? What would be the derivative of y cubed? Remember, y in essence is f of x, g of x, h of x. It's a function of x. So what is the derivative of g of x to the third power? Okay, it's 3g of x times g prime of x. So 3y squared y prime. Okay, so this is 3y squared y prime. Now the right side, let me put a raised dot. Think about this as a product rule, okay? The product of 6x and y. So the derivative of 6x is simply 6 times y, and the derivative of y is y prime times 6x. So I want to make sure we understand what happens. It's pretty straightforward. From here on is a basic algebra. X cubed gives you 3x squared. Y cubed, 3, y squared dy dx, or y prime. It doesn't matter which one you write. You write what they ask you if you're doing the homework or exam question accordingly. Either way is fine, y prime dy dx. Now, when you look at this part, okay, you can keep the 6 out as a multiplier or just get it involved with one of them. Either way makes no difference. And I'll show you that in a moment also. So if you get it involved with x, then the derivative of that one becomes 6 times y by the product rule, and the derivative of y is y prime or dy dx by 6x. If you want to go that route, by the way, just in case, because I've discussed that before, if you want to differentiate this and write this as 6 times xy, just this part, the differentiation would be 6 times. X gives you 1 times y, plus y give you y prime times x. And by the way, y prime is the same as dy dx. One may find it easier to write that way. It is absolutely your choice. Class is still not that big of it. Practically, we are done. As far as calculus is concerned, we are done. Here's the algebraic technique. What is it that you want to solve for now? Dy dx. So you have to collect everything involving dy dx on the same side, and the rest move to the other side. So whether you bring it to the left or right, it's up to you. So you move this guy to the left, this guy to the right. And so you get 3y squared dy dx minus 6x dy dx over 6y minus 3x. All right. We are going to solve for dy dx, and we notice there's a common factor of 3 on both sides also. We factor the 3 dy dx on the left. Okay. We factor the 3. Okay. And notice what happens. The 3 and the 3 cancel out. And so dy dx becomes the right side over the parentheses of the left side. And you're done. Okay. The only thing I want to add, because I've seen sometimes students having a difficulty with that, is that the way we moved is fine and dandy. If you move it in a different format, you may end up with the following answer. So take a look. If you ended up with x squared minus 2y over 2x minus y squared, it's the same thing. In other words, the top and the bottom are being multiplied by -1. So when would that happen? If we move differently, if we go back to the first step, if this was moved to the right instead, this would be the result. It means absolutely the same thing, and that's important for everybody to see. They are the same class, okay? It's just the way you move it, okay? All right, we want to deal with this, and again, number 4 class can be just a multiplier or pick it up as part of, let's say, x squared. Now, I'm going to put a raised dot in between just to make sure everybody understands we need to use the product rule on this. We need to use the product rule on this. Okay, so how do we do that? 4x squared, that gives us 8x times y. Y gives us y prime or dy dx times 4x squared, plus What is the derivative of 2y squared? 4y, y prime, or dy dx. And this is a number. It doesn't matter what type of number and how big or small, the answer is 0. Again, done with calculus. So what are you going to do? You're going to move 8xy, because you're solving for y prime, remember that. You're going to move 8xy, becomes negative 8xy, and you're going to factor out the y prime. And since we noticed there's a common factor of 4, we actually take the 4 also out. And so when you divide the right side by 4 times x squared plus y, the 4 drops. Okay. I hope you see how this thing has worked out. We have factored these two pieces, okay? It's a simple factoring. We have moved 8xy. And a common factor of 4 is dropped. And this is our final answer. Now, whether you put the negative sign in front of a fraction bar or at top makes no difference.
Professor?
Yes, go ahead, please.
Could you please explain how you went from the first step to the second step? I'm a little bit confused.
All right, let's do it again. So let's look at this part. 4x squared times y. What is the derivative of 4x squared? This is a product rule, okay? The derivative of 4x squared is 8x times y. What is the derivative of y? dy dx or y prime times 4x squared. You're okay with this part? In fact, do you see that 4x squared y gives us this? Do you see that? So one more time. 4x squared times y. 4x squared gives us 8x times y by the product rule. Y gives us y prime times 4x squared by the product. 2y squared is 4y, y prime. A constant results in 0. Is this making sense? Are you okay with that?
Yes, that makes sense now. Thank you, Professor.
Perfect. Perfect. Okay. Let's do this one. Okay, let's give everybody a moment. Remember, we have only one step of calculus, so I want you to think about this and tell me what you get. Give me your very first step, which is a calculus step. Differentiate term by term. So let's go. 4x squared. The derivative is? Anybody?
8x.
8x, done. 6y. What is the derivative of 6y? Class, remember what y is. Y is a function of x. Y is the dependent variable. Okay? It's important to know when you have an independent variable x, okay, let's just write this at top. Independent variable. If you're taking the derivative of x, the answer is 1. If you're taking the derivative of t, the answer is 1. If you're taking the derivative of theta, the answer is 1, assuming those are the independent variable. If y is an independent variable, works out the same. However, when the variable is dependent, dependent. What is the derivative of y? Y prime. What is the derivative of g of x? G prime of x. It's important to see y is the same as g of x. Therefore, going back to the question again, we know the derivative of 4x squared is 8x. It's not a big deal. What about 6y? It's 6y prime. Okay? What is the derivative of y squared, class? Anybody?
2y, y prime.
That's it. 2y, y prime. What is the derivative of g of x to the power of 2? 2g of x, g prime of x. The same thing. And the right side, what is the derivative of the right side, class?
E.
0, because e is a number. The right side is a number. The derivative of any constant is 0. We're done. We just got to solve for y prime, which means you move the 8x, you factor out the y prime here. Okay. Okay, class. And so you divide by 2 times 3 plus y, and you drop a common factor of 2. Okay. You divide by 2 times 3 plus y, and you drop a factor of 2. In fact, we can even drop it right now as follows. This 2 goes away, and this becomes negative 4. Okay, that's another way of writing. So you are dropping a common factor. So I hope everybody is comfortable with that. You need to practice with this, okay, class? All right, we want to find dy dx in the same manner, and the very first thing we need to know is that this is a product rule. So I'm going to put a raised dot between x and e to the power of y. That's hard to see. Let's see if we can make it a tad easier to see. So put a raised dot between the two. Okay. So x e to the power of y plus 2y cubed equals 3x. Now, it's a simple product rule, the first piece, class. It's a simple product rule. So can anybody tell me what is the derivative of this piece? X times e to the power of y. How would you differentiate this? Okay, so x, the derivative is 1 times e to the power of y plus e to the power of y. What is the derivative of e to the power of y? Remember, any exponential, the derivative is itself. So e to the power of y. Because the exponent is not x, rather a function of x times y prime or dy dx by the product rule times x. Okay, so maybe I write this because I want to make sure everybody understands what's happening. Take a look at just the first piece. So the first piece, class, is x times e to the power of y. So therefore, x gives us 1 times e to the power of y. We are looking at the product rule. What about e to the power of y? E to the power of y, the answer is itself, e to the power of y. Why? Because it's an exponential rule. And therefore, we continue with more. We look at the exponent. The exponent is a function of x, not x, so times y prime. And then by the product rule, times x. So that's just this first piece. The rest are easy. 2y cubed. What's the derivative for 2y cubed, class? 2y cubed. Nobody?
Would it be 6 y squared?
Times?
6 times y squared?
No, 6y squared times y prime.
Y
This
prime,
is
yeah.
not, it's important for everybody to understand. Y is not the same as x. Y is a function of x. The derivative of x is 1, everybody. But the derivative of y is y prime. So 6y squared y prime and equals 3. Okay, so this part gives us this 2 that was explained here by the product. 2y cubed, 6y squared y prime. I can't emphasize this enough. You got to understand the y prime and why you use that. It is the chain rule. Okay, because literally change the y to g of x or h of x or f of x. You're raising it to the third power. What is the derivative of g of x to the third power is 3g. G of x to the second power times g prime. The right side is a simple case, you get 3. You're practically done. All you have to do is solve for y prime. I'm assuming everybody has an easy time doing that. So just these 2 pieces, take the y prime out and move this one. So these 2 pieces, when you take the y prime out, the first piece gives you e to the power of y and x, so you put the x in front. The second one, simply put, gives you the first piece, which is 6y squared. And e to the power of y goes to the other side, becomes negative. You divide both sides by the parentheses, and you're done. This is the factored format, everybody, for that part. You factor it, you're done, everybody is happy. I hope you see that it's fairly simple, everybody. It's just a matter of practice, and it becomes easy. All right, we want to find the equation of a tangent line, and we do the same as before. We need 2 things. We need a pair, it's given. Notice, if you replace the x with -1 and y with +1, the equality works. Or in case if x is given, you can plug in and find y. The pair is given. Now the next thing is to find the slope. To find the slope, you have to find y prime or dy dx, and understand you put a raised dot in between and make this a product rule. So let's do this one by one. X squared, the derivative is 2x times y squared. What is the derivative of y squared, class?
2y y prime.
Beautiful. That's it. You got it. 2y y prime by the chain rule times x squared, and the right side is a number, so it gives you 0. So one more time. X squared gives you 2x times y squared by the product. Y squared gives you 2y y prime times x squared by the product rule. This is a number. Doesn't matter one or any other number. The answer is 0. All right. So you have 2 choices, class. You can solve for y prime, or you can even plug in right now and calculate the y prime, and that becomes this slope. If you plug in just the way it is, or if you solve for y prime. But it's really, to me, it makes more sense to solve for y prime. That's an easy case. You move the 2xy squared to the other side, and you do the division, okay? So you are going to divide both sides by 2yx squared, and it simplifies into negative y over x. The rest is all algebra. Again, class, calculus. Look at this one, calculus, 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 no more. Everything else is algebra. That's why I'm hoping you follow that, and it goes pretty fast. So I'm going to put the pair in. and that becomes the slope. So the slope is 1, and then y minus y1 equals m times x minus x of 1. Again, nobody has any problem with that. We are using, again, I'm going to write that for you in case quickly. We have y minus y1 equals m times x minus x of 1, known as the point slope. Point slope, everybody, okay? So I hope you are fine with that. I think we are good to go. So let's do that. We are continuing with implicit differentiation. Please understand, you want to put a raised dot in between and understand this is the product of x and cosine y. So x and cosine y. Just that piece, can anybody tell us the derivative of x times cosine y? What do you get? Using the product rule. The derivative of x is 1. So 1 times cosine. What is the derivative of cosine? Negative sine. Same argument, negative sine y. By the chain rule times y prime. By the product rule times x. 2y cubed gives us 6y squared, y prime, 3x gives us 3. Now you can use y prime or dy dx, either way is fine. So one more time, notice, x gives you 1 times cosine y. Cosine gives you negative sine y. Because it is y, gives you y prime by the chain rule. And because it's being multiplied by x by the product rule with x. Okay. Now again, all you have to do, move this part. So cosine y moves, then you have y prime, and you factor out. Notice these two pieces give us this. This goes to the other side minus. Divide both sides by the parentheses, and you are done. It's that simple, class. As long as you get the first step, the rest of the steps come together easily. So I'm interested in the first step. As long as you can do that, my assumption is you have no problem with the rest, because honestly, the rest would be basic algebra. Basic algebra. So we shouldn't worry about that. Let's go to the next example. All right, we are differentiating using the product rule again. So again, you put a raised dot in between. Y and sine x squared. In fact, that's just, you put a raised dot here. And you put a raised dot here. So product rule, class, product rule. Okay, now that we know that, let's do it one by one. What is the derivative of y? Y prime or dy dx. Since it says find dy dx, let's go with dy dx. The same thing as y prime. If you are uncomfortable with that, change it to y prime. It's the same thing, class. Let me just write that. This is the same as y prime. Okay, class? This is the same. The only difference is it's more precise. Sometimes you may have dy dt. You can still represent it with y prime, and we're going to come across that as of the next section. So it's important to understand the concept. So having said that, y gives you y prime times sine x squared plus sine x squared. The way I'm going to differentiate this, I'm going to read it sine. That's it, sine. So the derivative is cosine. Then I'm going to write the same argument, which is x squared. And I need the derivative of x squared by the chain rule, which is times 2x, and then times y by the product rule. On the right side, x gives me 1 times sine y squared. And sine, again, gives me cosine y squared. Now times the derivative of y squared. Okay. The derivative of y squared is what? 2y y prime times x by the product. So notice what we get. Let's go over it one more time. Y gives you dy dx times sine x squared. Sine x squared gives you cosine x squared times 2x. You're multiplying it by y by the product rule. This y is by the product rule. Right side, x gives you 1 times sine y squared. Sine y squared. Sine gives you cosine, so cosine y squared. Y squared, 2y, y prime or dy dx, and then by the product rule times the first piece, which is x. You're done with calculus. So what did we do? We solve for dy dx, which means you have to bring everything involving dy dx to the same side. So you have a choice. You can move this one or you can move this one. It makes no difference. So here's how the moving has taken place. I want everybody to see what happened. You keep this one intact and you put the sine x squared in here. When you move this one to this side, it becomes minus. So what do you have? Cosine y squared, 2y and x. Their product is 2xy cosine y squared. I hope you see that. This part and you factor out the dy dx, it's negative 2xy cosine y squared. Now, sine y squared, and then you're going to move this one, becomes negative. My apologies, this one becomes negative. So let's do this. Minus, and you put the 2xy in front. Divide both sides by the parentheses and you're done. Okay, and there's nothing you can do to simplify this further. It's important to see that it is a done deal, everybody. It is a done deal. Okay, all right. Equation of a tangent line. We need two things. We need a pair. It's given. We also need the slope, which requires differentiation. So what we are looking at here, again, I put a raised dot. We are looking at the product rule for each case. Okay. The derivative of x times e to the power of y. X gives you 1 times e to the power of y, plus e to the power of y is itself e to the power of y, times y prime by chain rule, times x by the product. Done. Plus y gives us y prime times e to the power of x. E to the power of x is itself times y. And the right side is 0. So one more time. X gives you 1 times e to the power of y. E to the power of y gives you e to the power of y, y prime, and then times x by the product. Y gives you y prime times e to the power of x. And then e to the power of x gives you e to the power of x times y. All you have to do is solve for y prime. That means you are going to keep this and factor out the y prime. You want to move this, becomes negative. You want to move this, becomes negative on the other side. So I hope you see what happens here. These two pieces okay. When we factor out the y prime, we have this. And the other two pieces, simply put, they move to the right and both take a negative sign. They both take a negative sign. Now, divide both sides by the parentheses, and this is what you have. And so, plug it in order to find the slope. Let's plug it. Okay, so what do we get? We replace the x with 0, and we replace the y with 1. So over here, minus e to the power of y, that means e to the power of 1, plus e to the power of x, that means e to the power of 0, which is 1, times y, which is 1. So this whole thing becomes 1, okay? And this becomes e. So minus e plus 1. The denominator, since x is 0, this goes to 0. 0 times this number is 0. And then e to the power of x is e to the power of 0 or 1. So I hope you see that negative sign is intact. E to the power of 1 is e. And then these two, each one is 1 because e to the power of 0 is 1 and y is 1. Their product is 1. The denominator, anything times 0, right? E to the power of 1, okay, that is e times 0. So this is 0 and this is 1 and this is what you get. And then now y minus y1. Just write that for you and you can finish that. So y minus y1 equals m times x minus x of 1. Okay, but it is easier to use just y equals mx plus b because this is the y-intercept. So you don't need to use the point slope. Okay, so I wrote that because I don't want anybody to think it can't be done with that. It can, but you really should avoid using that because it just takes much longer and you don't need to use it. Okay, everybody? Can I use the point slope? Yes. Should I use it? Absolutely not. Why not? Because whenever the intercept, namely the y-intercept is given, just it's faster to go y equals mx plus b. And by the way, in calculus, if e is given or pi is given, you use them accordingly. You don't change them to a numerical value because those are precise numbers. Okay. Finding y double prime. This thing is a little bit involved. It has a lot of steps, most of which are algebra. So let's start, and again, just a couple of simple calculus steps I want to go over. But it is important for everybody to see that there are a lot more algebraic steps than calculus steps. So having said that, how do we find the second derivative? Well, first we have to find the first derivative. So ignore y double prime, let's stick with y prime, okay? So to do that, let's do it one by one. X squared, 2x. Put a raised dot between x and y. And now it's the product rule. X gives you 1 times y. Y gives you y prime times x. By now you are comfortable with that, I hope. And y squared gives you 2y prime. The right side number gives you 0. So quickly, x squared gives you 2x. X times y, that means 1 times y, plus y prime times x. And then y squared is 2y prime. Okay. Now, you can solve for y prime easily by putting these two together and factoring the y prime, taking the rest to the other side, that shouldn't be a problem. I hope everybody understands how this is done. Just quickly, this part, class, is y prime times x plus 2y, okay? And so when you move this 2 to the other side, you get minus 2x minus y. So that's how you get to y prime. And you have a choice. You can leave it just like that, or you take out the negative sign and you put it here. Please understand that there is a negative at top. Both of them are negative, or you put the negative in front of a fraction bar and it makes no difference. Either way is fine, okay? All right, let's say we're done with y prime, okay? So if the question was what is y prime and then what is y double prime, you would do that. But I did that on purpose. You really don't have to go that route. What you can do right here, by the way, you can continue differentiating again to get to y double prime. I did this to say, in case the question is asking what is y prime and then what is y double prime, okay? Otherwise, you don't have to do that. So I want everybody to be clear as to why we are doing this, okay? So having said that, we really have to go back to the same format, if you will, so we can do the cross product, if you will, and then we bring them to the same side again. So in other words, I'm going to continue with this in essence, class. I want you to see the very first part that I got. I'm going to continue with that. That's what I'm doing. This is the cross product of this and putting it back. But you don't even have to do that. Again, why did I do this? Because let's say there were two parts. What is part A, y prime? What is part B, y double prime? If they don't ask you for y prime, you really don't have to even solve that. Just right from here, continue on. Okay, I want to emphasize this. Okay, so I wanted to show you what's y prime. Now let's take a derivative again, one by one. One more step of calculus, and believe it or not, calculus is done, and all is left is algebra. 2x, the derivative is 2, done. Y, the derivative is y prime. Now, y prime, the derivative is y double prime times x plus x, the derivative is 1 times y prime. We are using the product rule, class. We are using the product rule here. So y prime gives us y double prime times x. X gives us 1 times y prime. Over here also, put a raised dot between 2y and y prime. So you are using the product rule. What is the derivative of 2y? 2y prime times y prime. What is the derivative of y prime? Y double prime times 2y, and the right side is a number, so it becomes 0. So let me make sure everybody understands what's going on here by doing this. Y prime x, okay, is this part, everybody. Take a look at that part. Y prime x using the product rule is that piece. Two y prime is this piece. Product rule, again, as long as we understand that, practically we're done. 2y gives you 2y prime, and then times y prime. And then y prime gives you y double prime times 2y. Of course, I hope you understand what's happening now. You have to solve for y double prime. That's all there is to it. Now, to solve for y double prime, y prime has to be replaced with this. So you need this here. Y double prime, I don't know. X, Y prime will be replaced. Y prime times Y prime. Please understand this means Y prime to the second power. Okay, that's the idea. So what do? First, we solve for Y double prime, okay, by collecting like terms, and then we plug in. So let's do algebra. Every step from now on is algebra. Okay, so I showed you how that thing works. Let me erase this. Give me a second. So I'm going to erase this. I'm going to erase this. And all I'm going to do is just to do this. So you know which one is which. Now we put these two together because Y double prime is in common. Okay. And we factor out Y double prime. You get X plus 2Y, and everything else goes to the other side. Take a look. 2 goes to the other side. Y prime goes to the other side. This one, and everything takes a negative sign on the other side. Okay, I'm just showing you the algebraic technique. You should be having an easy time with that. Okay, so what happens now? Y double prime is the right side divided by X plus 2Y, okay? And replace the Y prime. Let's go with this. Replace the Y prime with this one, or this one, and then Y prime squared, the same thing squared. So take a look at what happens. So the right side, you can factor out the -2. Okay, I hope everybody can see that. So minus Y prime minus Y prime squared. So that's what happens, okay? And now we replace the Y prime, and there you have it. So the Y prime is replaced by this, and there you have it. All right, what is Y double prime? Well, we have to do two things. We have to divide by X plus 2Y, and we have to combine like terms and take a common denominator here. So let's see what happens. We're going to do all of it in one shot. So take a look. First and foremost, we're going to divide by X plus 2Y. So this is -2, we divide by X plus 2Y. But what about this one? If a common denominator is X plus 2Y squared, this one becomes 1 times X plus 2Y quantity squared. This one becomes minus 2X plus Y times X plus 2Y, and the numerator in this case, 2X plus Y quantity squared remains. Now, you have to square this, you have to distribute this, you have to square this and simplify the numerator. I'll leave it for you to do that, but notice what happens. First and foremost, you have the 2, that's fine. The denominator is X plus 2Y, and this one becomes X plus 2Y to the power of 3. And then you add them all up accordingly. For example, this one becomes X squared plus 4XY plus 4Y squared. This one is this class. Okay. This one is this part. And the last part. Now you combine them. And this is what you get. I'm assuming there's a lot of algebra here, class. I'm assuming we are comfortable with that, okay? I'm assuming we are comfortable with that. Now there's one more interesting step, and it will finish the job. Notice the very beginning, X squared plus XY plus Y squared equals 3. So take a look. So I can replace this with what? number 3. And so this becomes 3 times 3 or 9. And here's the final answer. So I want to repeat that. I want to make sure everybody understands what happened here. This is equal to 3. And what's inside the parentheses is 3 times that. So 3 times 3 is 9. 9 times negative 2 is negative 18. This is a very long question, and it may not be a fair question for the exam. But trust me, it really challenges your sense of implicit differentiation as well as your algebra. I highly recommend you go over that to make sure you're comfortable with the concept class. Okay, class? All right. Trigonometric functions, we've looked at their derivatives. Now let's look at the inverse trigonometric functions. And we have discussed them previously when we discussed inverse functions, and you know how we deal with them. Now, of course, the most important thing is to understand the meaning. When we say sine inverse x equals y, that means sine y equals x. Okay. Now, these are the formulas for the inverse functions, and we're going to look at the proof for a couple of them, and I highly recommend you try working on a couple of them on your own for practice. What you see here on the right side, this is from trigonometry. We discussed it in the beginning of the course. Okay, and inverse functions, their composite function is x as long as it's within an acceptable domain and range. If you recall, we had to restrict the domain of every trigonometric function to make them one-to-one because none of them is. Every one of them is a periodic function. And the restriction, for example, on sine was we put it between negative and positive power 2. Okay. And so that was the restriction on sine. Okay. And of course, the range is from negative 1 and 1, and everybody remembers all of those. In the case of the cosine, we go from 0 to 1. So let's look at the first one as an example. Sine inverse x equals y. We want to differentiate that. Okay. So I'm looking at this one, sine inverse x equals y. That means sine y equals x. So I want to differentiate that, and I wouldn't know how to differentiate this one, but this one I can differentiate using implicit differentiation. So everybody, implicit differentiation. Sine y. What is the derivative? Cosine y times y prime or dy dx equals x gives us 1. So we are doing implicit differentiation, differentiation. So what is dy dx? 1 over cosine y. Okay, and now we know that sine squared plus cosine squared equals 1. Okay, class? Sine squared plus cosine squared is 1. Cosine is the square root of 1 minus sine squared, and sine is represented by x, so square root of 1 minus x squared. By the way, this is plus minus because of the restriction. In the fourth quadrant and the first quadrant, cosine is positive. This was discussed when we discussed inverse trigonometric functions. But let's quickly recap. Sine y gives you cosine y dy dx. X gives you 1. So dy dx is 1 over cosine y. If sine y is x, cosine y is the square root of 1 minus x squared. Okay, again, where does it come from? Sine squared theta plus cosine squared theta is 1, which means sine squared is 1 minus cosine squared, and cosine squared is 1 minus sine squared, and so on and so forth. So it's pretty straightforward. I hope everybody is okay with that. Therefore, you are going to replace the cosine y with square root of 1 minus x squared, and that's a proof for derivative of sine inverse is 1 over the square root of 1 minus x squared. Okay, class? So that's one example and the proof. Let's look at tan inverse. By the way, on the right, again, I have the formulas for you, class. What I want to mention is that the sine inverse and cosine inverse, the difference is -1. The derivative of tan inverse is 1 over 1 plus x squared. For cotangent is the same thing, you make it negative. For secant inverse is 1 over x squared of x squared minus 1. Cosecant inverse is the same thing, just change it to a negative sign. So pay attention to, and as long as you know 3 of them, you know the rest of them. So what is the derivative of tan inverse? Again, we don't know. Let's do write that again as what? Tan y equals x and do the implicit differentiation. Okay, so again, I don't know the answer to that. We just want to get here. We want to prove this. We want to prove this. So tan y equals x by definition of an inverse trigonometric function. Now let's differentiate. What is the derivative of tan y? Is secant squared y by the chain rule times y prime, and x gives you 1. So secant squared y prime or dy dx. So therefore dy dx is simply 1 over secant squared y. Now we have to find the relationship between tangent and secant, okay? And everybody remembers, again, the Pythagorean theorem. Okay, remember, so let's just write the first one, that sine squared plus cosine squared is 1. This is the one we, part of Pythagorean identities. Then we have tan squared plus 1 equals secant squared. Okay, remember that, class? And then cotan squared plus 1 equals cosecant squared. So those are the Pythagorean identities. I'm reminding you of, okay. So we're going to use that, okay? Maybe I need to, I will erase it later on. So secant, therefore, is tan squared plus 1, okay? So if you go back here, x is tan, so tan squared, that means x squared plus 1. And that's the answer. So the derivative of tan inverse is equal to 1 over 1 plus x squared. We proved that. Pretty straightforward. Okay, class? I hope everybody's comfortable with that. I highly recommend you do a couple of them on your own for practice. Just mimic what we did. Do cosine, okay? Do secant, okay, on your own. All right. Let's look at the derivatives of inverse functions. The very first thing we need to realize, this is sine inverse to the power of -1. Please understand, this -1 is going to be different than what we are discussing. Remember, when you have a denominator, you can bring it up with a negative exponent. Let's assume this was to the power of 5, you would bring to the power of -5. That sine inverse is intact. So you want to take the derivative of sine inverse to the power of -1. This -1 is different than this -1. This -1 refers to inverse of sine. This means to the power of -1. So do not mix them up. So how do we differentiate that? Let's quickly look at the concept. You remember the extended power rule. So this exponent sits in front, and then you write the same thing to the power of 1 less. So this becomes to the power of -2, okay? So this sits in front, then the same thing remains, and the exponent goes down by 1 minus 1 becomes -2. By the chain rule, the derivative of the inside, we just write this. I hope you see that. So negative, okay, 1 sits in front. This one takes the exponent of -2, and then you differentiate this. Differentiation, you put this one next to it. And by the way, this one with the exponent -2 can go down and becomes +2. Never mind And don't forget the negative sign is not going to go anywhere. It's going to persist. Okay. I hope everybody's comfortable with that. Okay. All right. Part B. Let's see what happens here. First, we put a raised dot in between. Okay. So it's a product rule. X gives you 1 times arctan. By arctan, we mean tan inverse. Okay, you can write it that way. So 1 times tan inverse of square root of x. Now, what is the derivative of tan inverse of square root of x? If you use the formula, okay, remember, it's 1 over 1 plus x squared. But if it happened to be u, and let me write that for you. If it happened to be, let's say, u here, okay, so it's sine d, okay, so if you have sine inverse of u, then you have du over square root of 1 minus u squared. This one would be, again, du over 1 plus u squared. U is a function of x. U is a function, okay, u is a function of x. So with that being the case, in this case, this is u. So what you do, please understand u is square root of x. So 1 times arctan square root of x, then 1 over 1 plus this thing is squared and times the derivative of square root of x. So let's see what happens. I want to make sure everybody understands this step, so let's go over that. So x gives you 1 times tan inverse. But what about tan inverse? I want to make sure we understand that. 1 over 1 plus u squared, the u is square root of x, u squared. And then times the derivative of the square root of x, which is 1 over 2 square root of x. By now we've done that. And then by the product rule times x. I hope everybody remembers the derivative of square root of x class is x to the power of 1/2, and its derivative is 1/2 x to the power of negative 1/2, or 1 over 2 square root of x. That's how we arrive at this one, okay? So one more time. X gives you 1 times tan inverse. Tan inverse gives you 1 over u, whatever this one is, u, square it, okay? The derivative of that, du, it sits in, whether you sit it in front or next to it, it means the same thing, class, times 1 over 2 square root of x. And this is by the product rule. Now, when you put this whole thing together, you get tan inverse of x, and then plus square root of x over 2 times 1 plus x. I want to know how we arrive at that. This one, everybody, is x, so that's 1 plus x. This is 2, and then x and square root of x. We can write it as simply square root of x at top. So let me just maybe do this for you. These two give you square root of x, okay? And this one is changing to x. Okay, everybody? All right, here's the next one. G of x is square root of x squared minus 1 times secant squared times, my apologies, secant inverse, okay? So here's what we get. The product rule again. So you put a raised dot in between. Now the first one, we write it to the power of 1/2, so we can do the differentiation. Okay, so let's see what we get. 1/2 x squared minus 1 to the power of negative 1/2 times 2x, and then times secant inverse. Now what about secant inverse? Just write this one. Just write this one times the first piece. So let's quickly recap. From the blue one, 1/2 sits in front. X squared minus 1, you raise it to the power of 1/2 minus 1, negative 1/2. By the chain rule, the derivative of the inside is 2x. By the product rule, times secant inverse. So that's done. What about secant inverse? Simply put this one. Okay, you have it here. And then by the product rule times the first piece. Now we're done. We have to do calculus part, which is very simple. I hope you see the answer. Okay. 2 cancels out the 2. Negative 1/2 goes down, becomes positive 1/2, which is the same as square root. X is at top, secant inverse is at top. Okay, class? X squared minus 1, x squared minus 1 under the radical, they cancel each other, we get 1 over x. In other words, let's just make sure we understand what happens. This part cancels out this part, and this is the same as this part, class, where 2 cancels out 2. Okay, it's pretty straightforward. We're going to look at the last example again, and you got to practice with it. X cosine inverse of x minus the square root of 1 minus x squared. Again, let's put a raised dot between x and cosine inverse, so we know it's a product rule. So what is the derivative of x? Simply 1 times cosine inverse. What is the derivative of cosine inverse? Negative 1 over the square root of 1 minus x squared. So this is sine inverse. Cosine inverse has negative 1 in front. Okay, class? And then minus. This part, of course, we've already done that. We have to change it to 1 minus x squared to the power of 1/2. And then 1/2, 1 minus x squared to the power of negative 1/2 times negative 2x. We've done it many times by now. I hope you're comfortable with that. So quickly and one more time. X gives you 1 times cosine inverse. Cosine inverse gives you negative 1 over the square root of 1 minus x squared times x. The second part, 1/2 sits in front, so minus 1/2, the same thing to the power of negative 1/2, and then times negative 2x by the chain rule. So all you have to do, rewrite everything very carefully. Notice, this is cosine inverse. This one has negative sign, you put it here. X comes at top. This one, negative 1/2 and negative 2 cancel each other, they give us plus. Please understand that. Negative 1/2, negative 2, they give us plus 1. X sits at top. This one with the negative 1/2 goes to the bottom with the positive 1/2. These two are opposites, cancel each other. And you end up with cosine inverse of x. And this is it.